about to embark on a journey. On this journey, where you will see this universe in a way you have never witnessed before, we will explore 10 unique wonders. Amidst all this chaos, the violent collisions, the exploding stars, you will truly realize just how small our Earth is. Europa, Jupiter's moon. Beneath the icy surface of Jupiter's moon, Europa lies, one of the solar system's most tantalizing mysteries. We are about to visit a world where an ocean larger than all of Earth's combined may harbor the potential for life. Europa's cracked, icy surface resembles a shattered mirror, hiding an ocean up to 100 miles deep. Scientists believe this liquid water is kept warm by the gravitational pull of mighty Jupiter, creating tidal forces that heat Europa from within. The ocean floor might feature hydrothermal vents, just like those on Earth, where life thrives in complete darkness. As we move away from this icy enigma, we can only wonder what secrets Europa holds beneath its frozen shell. Light speed. If we could somehow accelerate to near light speed, strange things would happen. Time would slow down for us compared to everyone else. At 186,000 miles per second, it is the cosmic speed limit that shapes our understanding of reality. Nothing in the universe can travel faster than light. The stars ahead would shift colors, clustering in a bright central point, while the space behind would darken. At these speeds, a collision with even the smallest space particle would release energy comparable to a nuclear explosion. Though we may never reach it physically, light speed represents the edge of what's possible in our cosmos. Pulsars. Imagine a star so dense that a teaspoonful would weigh billions of tons, spinning hundreds of times per second and shooting beams of radiation like a lighthouse in space. Welcome to the realm of pulsars. Born from the explosive deaths of massive stars, pulsars are incredibly compact neutron stars. Their powerful magnetic fields channel radiation into narrow beams that sweep across space as the star rotates. When these beams cross Earth's path, we detect regular pulses of radiation. Some pulsars rotate with such perfect precision that they outperform our best atomic clocks. These cosmic lighthouses have even helped scientists confirm Einstein's prediction of gravitational waves. As we leave this spinning wonder behind, remember that pulsars represent nature's perfect demonstration of extreme physics. Magnetars. Prepare yourself as we approach the most magnetically powerful objects in the universe. These rare cosmic bodies possess magnetic fields so intense they would destroy your credit cards from half the distance to the moon. Welcome to the world of magnetars. Magnetars are a special type of neutron star with magnetic fields trillions of times stronger than Earth's. This incredible power comes from their ultra-rapid rotation at birth, which amplifies their already strong magnetic fields to unimaginable levels. The immense magnetic forces twist and strain the magnetar's crust until it fractures, releasing enormous bursts of energy. In 2004, one such burst temporarily altered Earth's upper atmosphere despite coming from a magnetar 50,000 light-years away. Scientists believe magnetars are relatively short-lived, with their extreme magnetic fields decaying after about 10,000 years. Only about 30 have been identified in our galaxy, making them among the rarest and most violent objects in the universe. As we leave this magnetic monster behind, consider that nature's extremes often reveal the deepest workings of cosmic physics. Supernovas. Most spectacular explosions in the cosmos, nature's grandest farewell performance when massive stars die. In just seconds, a supernova can outshine an entire galaxy. Let's explore these cosmic catastrophes that create many of the elements essential for life. When a star at least 8 times more massive than our Sun runs out of nuclear fuel, its core collapses under its own gravity. This triggers a titanic explosion that blasts the star's outer layers into space at up to 10% the speed of light. The energy released in these few seconds can equal what our Sun will produce over its entire 10 billion year lifetime. Inside this violent inferno, intense heat and pressure forge elements heavier than iron, including gold, silver, and uranium, that scatter across space to eventually form new stars, planets, and even life. Some supernovas leave behind neutron stars or black holes, while others completely obliterate the parent star. Though appearing sudden, these explosions represent the final act in a drama that began millions of years earlier when the star first formed. The expanding shell of ejected material forms a breathtaking supernova remnant, a glowing testament to the star's violent demise. As we depart this brilliant cosmic firework, remember that the atoms in your body were once forged in such stellar explosions. Kepler-438b. We now journey to a distant world that challenges our imagination, an Earth-sized planet orbiting a star 640 light-years away that might have conditions similar to our home. Welcome to Kepler-438b, one of the most intriguing exoplanets ever discovered. Discovered in 2015, this world orbits a red dwarf star smaller and cooler than our Sun. Kepler-438b sits in the habitable zone where liquid water could potentially exist on its surface, the key ingredient for life as we know it. The planet receives about 40% more sunlight than Earth, making its surface temperature potentially suitable for water oceans. However, its parent star occasionally unleashes powerful flares that might strip away any atmosphere, potentially making the planet's surface hostile to life. With a size just 12% larger than Earth, scientists believe it's likely rocky rather than gaseous, another point in favor of potential habitability. As we depart this distant cousin of Earth, we're left wondering, in the vastness of space, how many worlds like this might harbor life forms gazing back at us, asking the same questions about our pale blue dot. Helix Nebula. Prepare to witness one of the most stunning sights in our galaxy, the haunting beauty of a dying star that resembles a giant eye staring back at us from 700 light-years away. We are visiting the Helix Nebula, also known as the Eye of God. Created by a star similar to our Sun in its final death throes, the Helix Nebula spans nearly 3 light-years across, about half the distance from our Sun to its nearest stellar neighbor. As the star ran out of fuel, it shed its outer layers in concentric shells that expand outward at about 20 miles per second. The star's hot, exposed core, now a white dwarf, emits intense ultraviolet radiation that causes the ejected gases to glow in spectacular colors. Oxygen glows blue-green, while hydrogen and nitrogen appear red. Countless cometary knots, dense globules of dust and gas, each about twice the size of our solar system, create the striking texture visible throughout the nebula. In about 5 billion years, our own Sun will create a similar cosmic masterpiece. As we leave this celestial eye behind, remember that stars create some of the most breathtaking vistas in our universe. TUN 618. Now we venture toward the most massive black hole ever discovered, a true cosmic leviathan. Brace yourself as we approach TUN 618, a supermassive black hole so enormous it defies imagination. Located about 10.4 billion light-years from Earth, TUN 618 weighs in at an estimated 66 billion times the mass of our Sun. If placed in our solar system, this monster would stretch far beyond Pluto's orbit. This giant black hole fuels something so incredibly bright, it outshines whole groups of galaxies. Yet all that intense light comes from an area smaller than the path our planets take around the Sun. Stuff falling into this black hole, called TUN 618, heats up immensely, forming a glowing spinning area that shines with the power of thousands of galaxies combined. At the same time, strong streams of tiny material shoot away from it at almost the speed of light. Scientists are still trying to understand how such a massive black hole could exist so early in the universe's life. One idea is that maybe it formed directly from huge clouds of gas collapsing, rather than growing from stars that died. Stepping back from this huge space object, TUN 618 shows us the truly extreme things possible in our universe and reminds us how much more we need to explore and understand about space. Quasar S5. Prepare to witness one of the most luminous persistent objects in the known universe. We are about to explore the Quasar's 514, a cosmic beacon so powerful it shines with the brightness of 300 trillion suns. Imagine looking very, very far away into space. Quasar's 5 is one of those incredibly distant things, about 12 billion light years from us. That's so far that the light we see from it today left a long time ago, back when the whole universe was just a baby, only 1.6 billion years old. So, looking at it is like using a time machine to see the early universe. What makes this quasar really amazing is what's inside. One of the biggest black holes ever found. It's truly huge, weighing about 40 billion times more than our own sun. Finding such a monster black hole that grew so big, so early in time, is another special thing. It makes scientists wonder how it got so massive so quickly. This giant black hole pulls in nearby gas and dust with its powerful gravity. But this material doesn't just fall straight in. Think of it like water swirling down a drain, but much, much hotter and bigger. It shines so brightly that if you could put it in the middle of our own Milky Way galaxy, it would look brighter than the full moon in our sky, even from thousands of light years away. To shine this bright, the black hole has to eat a lot. It swallows gas and dust equal to about 4,000 Earths every single day. It's a great example of how even black holes, which are known for being dark, can create some of the brightest lights we see when they are gulping down lots of space material. Dark matter. For our final and most mysterious cosmic miracle, we delve into something invisible yet seemingly everywhere. Something that makes up roughly 85% of all matter in the universe, yet has never been directly detected. Think about everything we can see. Stars, planets, even us. That's all made of normal stuff. But there's also something called dark matter. It's different because it doesn't interact with light or anything like it. We can't see it or detect it with our usual tools. Still, we know dark matter is out there because we can see its gravity pulling on things. Without the extra gravity from dark matter, galaxies would actually spin apart. The stars and gas we can see don't have enough pull on their own. In fact, scientists estimate there's about 5 times more dark matter than all the normal stuff combined. Dark matter acts like a giant, invisible skeleton throughout space, helping shape where galaxies formed and how the universe is structured. Scientists have ideas for what it might be, maybe tiny particles we haven't found yet, or even super-old black holes, but nobody has managed to capture or prove it directly. Finding it is one of the biggest challenges astronomers face today. Some even wonder if maybe we've got gravity wrong instead of there being missing stuff. As we finish looking at the universe's amazing features, dark matter shows us that the biggest secrets might be hidden right under our noses, making us rethink how reality truly works. Our space journey is ending for now. These 10 amazing sights show how much cool and different stuff is in the universe. Space is full of things that are hard to even picture. We only recently learned about some of these wonders. Others are still big puzzles for scientists. As we learn more, who knows what other amazing things we'll find. So look up at the stars tonight. Remember, you're part of this huge, mysterious space too. the tiny pieces that make you are also out there in the stars. Until next time, keep thinking about the wonderful universe all around us.